So this talk is about GENI, what GENI is about, how GENI is being built, how GENI is being used, how you can get how you can use GENI, and I will do a short demo as part of this talk so you get a feel for how one runs experiments on GENI. So kind of an outline for the talk. I think I'll just dive right in. So we already have global networks today. We use networks such as the internet, the best known global network. So we deploy these networks, but we really don't understand the science behind these networks. It's more of an engineering activity. We deploy it, we see how things work. If there are bottlenecks in certain places, we fix them. So the NSF would really like to see a science behind networks and a basic understanding of why networks work. Can we predict how they will work? There are also innovation issues with today's internet. Today's internet is a production network. We use it for mission-critical applications such as banking, medicine, Facebook updates, and so on. And so you can't really go to the internet or to an internet service provider. You can't go to AT&T or Sprint and say, hey, I have this really cool idea for a backbone routing protocol. You really should deploy this. It's really cool. They aren't going to let you do it. It's a production network. They're not going to let you mess with it. So all the innovation we see today in the internet happens at the edges. We have nice new clients, we have new services, but there is almost no innovation that happens in the core of the network. And then finally, we have issues about societal issues related to these networks. We deploy these networks, we use them, we know that there are privacy and security issues, but we don't really understand them, we really don't know how to deal with them. So to grapple with these challenges, to understand these challenges and to come up with solutions, the NSF is funding a large number of research projects, future internet projects, and GENI, where GENI comes in, it is a test bed where people with ideas for new protocols, for new ways of running networks, designing networks, can actually go and test out your ideas. Well, you can't test them out on the internet, and you can't test them out in your lab. Sure, you can, but you can only do that at small scales. And so GENI is a test bed where you can check out your ideas. You can test your ideas at scale. At scale means few hundred nodes, large enough scale that you can convince yourself and program committees that your research will indeed scale if it was actually deployed on a real network. So GENI opens up opportunities for leading edge research you cannot do on the internet, and we hope rapid innovation, since you can innovate not just at the edges but also in the core of the network. There are two key concepts that underlie GENI, and you'll see these concepts again.
Testing.
And you will see these concepts again and again throughout this conference and all the tutorials. The first concept is the notion of a slice. So GENI is a shared test bed. You have multiple people using this test bed, running multiple experiments in parallel. So a slice is a portion of the test bed that you get, a portion of the test bed within which you run your experiments. Hello? Can you hear me? Yep, great, thank you. So slicing is one key concept. So it is your share of the test bed, your experiment runs within your slice, and your slice is isolated from other slices, other experiments running in the GENI world. I'll come back to this concept later. Deep programmability is the other key concept. What that means is you can program the network at any level. You can program end hosts, you can program intermediate switches and routers, backbone switches. And you can, in the end host, you can put any the software of your choosing, any operating system you want. In the switches in the core, you can put your own software, which means you can do experiments with protocols other than IP. You can write your own routing protocols, your own define your own packet format, packet headers, and so on. So essentially illustrates this concept. We have the shared testbed. We have these two researchers. They both have their own slices. This researcher here, for example, might have virtual machines at some end hosts around the country, slices of network links, which means a VLAN with a certain bandwidth that connects his resources, and he might have resources or his software running in these switches in the core of the network that's doing his own custom packet processing. And she likewise is running her own experiment in parallel, and we hope would not interfere with one another. And the idea is now you can have multiple internets running in parallel. And this concept, in fact, is being used today. The NSF, as I said, is funding research in future internet architectures. There are 4 large projects that have their own vision of what the internet of the future might look like. And they each have their own slice in GENI where they run their own protocols, and they all, we'll see what evolves into the future internet, or maybe it's a combination of these research projects. So the GENI concept. I have a kind of a cartoonish example to illustrate how you might think of GENI. So here we have a researcher. He's a networking researcher with test tubes. I don't know why, but anyway, he has this idea of for a new protocol for networks. He says the original internet was designed to connect computers, which is what it was. It was to connect these essentially supercomputers at these various sites. He has an idea for a fundamentally new architecture, which is about connecting people. A lot of people have talked about this. And so he writes up a paper about this, and you get the usual kinds of reviews about, oh, this won't scale. What about privacy? What about almost anything that people, the usual kinds of critiques against this kind of work. So he decides, well, I'll try this out. I'll build it. So he starts off in his lab, builds a small test bed, checks out his ideas, and says, it's time for me to try this out on a larger scale. So he goes to GENI. He gets a few cloud computing resources. He gets switches in the backbone. WiMAX base stations. I know some people here have interest in WiMAX. GENI has WiMAX base stations, and connects them up in a topology that best suits his experiment, and sets up a measurement system so he can measure what's going on. And people hear about this experimental service he's running. They start using his experimental service. They like it. They tell their friends. More people start using it. He needs more resources. He goes back to GENI, adds more cloud computing resources or more switches. He learns a lot. He has real users using his experimental service. He's able to measure exactly what's going on in his experiment, and and he's able to grow his experiment as the number of users grow. He likes it a lot. This is how people might access his service. Some people might access his service directly over his non-IP protocol. They might install essentially an app on their smartphone or on their computer, which talks non-IP to his application. And some might come through the internet through some kind of a IP to his protocol gateway. So to most users, they may not even realize they're using a service that is not based on IP. They just install an app which happens to talk directly to the Ethernet on their computer and send packets over the Ethernet. So his experiment is a great success. He decides to take this off, spin off a company, get rich, publishes a lot, gets rich, and lives happily ever after. So I'm guessing not all GENI experiments will end up this way, but even if have to, will be great. So if you have a great idea for a protocol for new research, for new network architectures, the place you should go to for funding is the NSF SIZE Directorate. They fund research in this area, and what we would very much like you to do is use GENI as a test bed for testing out your ideas. And so just to keep in mind the difference between GENI and the other NSF programs that actually fund research in networking. You will hear tomorrow about a solicitation from the GENI project office that is out right now, where we are looking for interesting experiments to run on GENI. So if you have been having ideas and things that you that you would like to do but cannot do on the internet, you might want to think about proposing to this solicitation. There'll be details tomorrow. So GENI is meant to enable at-scale experiments. I mentioned opt-in users. This is people who are using your experimental services. They may not even realize that your services are running on GENI, and they just get access to cool services, and you get access to real users. So that's something that, again, we'd really like to see in new proposals for research experiments on GENI. So you may ask, how do we build GENI at scale? Well, here's a, so GENI is being built in spirals. Every year it grows larger in capabilities and in scale. I mentioned that we have backbone networks as part of GENI. A key piece of getting access to, connecting to the backbone networks are your regional networks. We have people from Florida, for example, so one of the things we're doing in this phase is growing the regional network footprint of GENI. So essentially getting more regional networks GENI enabled, making it easier for our experimenters to connect from their campuses to the GENI backbone networks, internet to a national under rail. And so that's an area of growth in GENI. We're also, you heard GENI racks mentioned many times. These are essentially, think of them as mini clouds, compute facilities, and they're connected with OpenFlow programmable switches to backbone networks. So those are being deployed at various locations around the country, and also new WiMAX stations, base stations. GENI also grows by this by notion of federation. What this means is, part of it is we deploy GENI equipment on campuses, GENI racks, and they are essentially federated with GENI, which means each campus owns and operates its own GENI rack. And they join the GENI Federation, and they say, hey, we are willing to let GENI researchers access these resources. They're available for our campus students, but they're also available for GENI researchers wherever they come from. So, and also we take existing test beds. EmuLab at Utah is a great example of an existing test bed that's federated with GENI. So it's got a GENI API on it. And as a GENI experimenter, now with your GENI account, you can get access to resources at the Utah EmuLab testbed. Likewise, Planet Lab is another testbed you might have heard of, federated with GENI. Deter testbed that was mentioned, they're all federated with GENI. So with your one GENI account, now you have access to all these resources, testbeds, existing testbeds out there. Same for campus resources. Campus networks using OpenFlow are now being made available for research as well as production use. So again, these are existing networks that we leverage by putting on a common API and a common credentialing scheme. One account, and you have access to resources around campuses. So that's essentially how GENI grows. Part of it is by deploying new resources such as GENI racks, and a large part of it is essentially GENI enabling existing testbeds and networks. Okay. And please feel free to stop me anytime with questions. So I already said a lot of really the message here is a lot of the deployments are happening on campuses, because that's where the early adopters are. Students are, we have a lot of students here still looking to use these new kinds of facilities for their research. students are more willing to install an app on their phones or computers and connect to experimental services. And so being able to connect to where our researchers and users are is important, and that's why a lot of the growth of GENI happens on campuses. Georgia Tech is a great example of a campus, one of the first campuses that are GENI enabled. Key to success in GENI enabling a campus is you have to have a researcher who's enthusiastic about it, and a campus CIO who's willing to work with a researcher. Because a lot of the work and risk falls on campus IT. They are deploying a resource on their campus network, which is essentially open to researchers from who knows where, or GENI researchers from anywhere in the country. They are willing to put OpenFlow switches on their campus, which essentially says, I'm going to give up part of my production network, campus production network, for experimental traffic. You know, and it's a production network. Something goes wrong, you're going to have a lot of tens of thousands of unhappy users. So it's really important that your campus CIO is on board, is involved. And in fact, for all these GENI rack deployment projects, we insist that the campus CIO be part of your proposal. This is kind of how we see GENI growing. We are heading in this direction. I'm not going to go into a lot of detail. Excuse me. All I'm going to say is the control plane of GENI. This is the where the protocols you use to discover resources, so find resources, get access to resources, put them and stitch together a network, your data plane. All that happens over the internet. So it's essentially web services running at locations with resources. We call them aggregates in GENI world. So, for example, EmuLab at the University of Utah, which is a testbed, runs an aggregate manager. So it manages Utah resources and hands them out to GENI researchers. Yep.
Could you repeat what an aggregate is again?
Sure. An aggregate is a collection of resources for experimenters at one organization. So, for example, a GENI rack at University of Utah is an aggregate. And so it's owned and operated by the University of Utah. It's a resource that's made available to GENI researchers. And it's a collection of resources at a site, essentially. And so every aggregate runs its own aggregate manager, which is essentially a web service. So you go, if you want resources from the University of Utah GENI rack, you would use your experimental tool, which talks over the internet to this aggregate manager and says, this experimenter would like 10 raw computers, raw PCs. And the aggregate manager will verify your credentials, make sure they're available, and say, sure, here they are, here are the IP addresses of these 10 machines you can have for your experiment. So every location with GENI resources runs its aggregate manager, and you talk to those resources. When I say talk to those, it's typically your tools that do that talking. You don't have to go to each one of them individually. Your experimenter tool would do that. Okay. Yep?
Racks and the aggregates are one and the same thing?
Yeah, a rack is a kind of aggregate, yes. So use the internet as a control plane to, that's what your tools use to talk to the aggregate managers, to the resource providers, and then you stitch together a data plane. So this is your, this could be a non-IP network that you're stitching together for your experiment. It might go over regional networks, go campus networks, research backbones. So you say, I want 5 machines at Utah, connected to 3 machines at Clemson, to Princeton, and you connect them in a topology that's best suited for your experiment. It's a layer 2 topology, so you essentially Ethernet VLANs is the technology used to connect these. And then on top of these, you can choose to run IP, you can choose to run some other experiment. So that's the data plane. So I'll be doing a demo later, I mentioned, and in that demo, I will be using essentially a web-based application which will talk over the control plane to get resources, essentially raw PCs, 2 bare metal PCs, and I'm going to connect them in a data plane. and have some traffic flow through. We'll see that. You heard GENI racks. Here's an picture of one of the GENI racks. It's got compute. It's a rack, as you can imagine. It's got lots of compute resources. It's got one of the switches there is an OpenFlow enabled switch, and that's the switch that connects compute resources on this rack to the backbone networks. So your data plane, your layer 2 network would go through the OpenFlow switch to your regional network or backbone network. And so it's an OpenFlow enabled switch, so you can provide your own OpenFlow controller and decide how you want traffic to flow within your slice. We are, as part of the build out of GENI, there are more WiMAX base stations being deployed. 5 to 6 regional networks are being GENI enabled, and GENI racks at 50 to 80 locations are being deployed. You'll hear a status tomorrow morning on how many have actually been deployed so far. I don't remember offhand. Yep.
You said layer 2.
Yep.
Is there some sort of layer 2 tunneling happening between the aggregates?
It's VLANs. It's all VLAN based. So it's you actually get.
How do VLANs traverse multiple sites? Is it through a layer 2 tunneling protocol?
So this GENI has a stitching protocol. So essentially, these various aggregates say, so I have VLAN 253 to 265 available. What do you have? And then we agree on and there might within the backbone there might be VLAN translations happening if there are switches that can do that. But there is this negotiation that happens that allows you to stitch a VLAN from say Utah to Atlanta. Yeah.
Question regarding WiMAX.
Yeah.
Any particular reason why that protocol was chosen? Because in the public networks, an alternate protocol was chosen, which is LTE.
Well, we would love to go LTE. The problem has been so the reason. Couple of reasons for why WiMAX. One, it turns out when the spectrum was assigned for WiMAX applications, campuses were given a certain kind of license to use. That was one reason. Two, we were able to get WiMAX base station software, which we could then use to GENI enable slice, so you can have multiple people using the same base station for different experiments. We would love to go LTE. We have not had much success getting commercial vendors to work with us. So, I mean, we've had discussions with Sprint, Clearwire, but hasn't gone very far. But if you have contacts with the LTE wireless industry, we'd love to talk to you.
They won't give it up.
Yeah, that's
a lot of money on it. So
that's not money there, right? Exactly. Yep.
Can we build these racks ourselves, or?
Oh, sure, absolutely. You can build the racks yourselves. You can buy a rack from Dell or Cisco, and the software is all available. We can help you get it on. But, yeah, we can do that. But there's also, the NSF you can put in an application. That'll come. Larry might be the next slide actually. How you can get these are the racks we deployed. If you would like to deploy a GENI rack, I'll eventually get there. It's very but anyway, Lyle Weber of the he's at the University of Wisconsin. He maintains his list of who gets GENI racks, and you need to get on his list. And then then he'll pay you to buy a rack. Essentially, pay your campus to buy a rack and get it installed. And, as I said, your campus CIO really needs to be involved.
Who's the next one?
Lyle Weber. There's a picture of him somewhere down here. See, extra GENI rack. This is the one out of Renzi and IBM. It's a fairly it's a high performance rack. It's got a lot of oomph. It's more expensive. And then there's the Insta GENI rack from HP and University of Utah. Not quite as resource rich as the extra GENI racks, but a lot less expensive. So there'll be a lot more of these. There are a lot more of these being deployed. WiMAX deployments, I'm not going to go through the list, but these are the campuses that are getting WiMAX. If you're interested in WiMAX, there's a tutorial on WiMAX tomorrow. This is an example of a regional network that's being GENI enabled. So essentially OpenFlow switches. where you can put your own OpenFlow controllers in the regional network. And the Internet 2 and GENI have a major agreement. So they provide backbone services. Internet 2 is also deploying OpenFlow in the backbone, and which is great for GENI. Some of these sites where Internet 2 plans on deploying OpenFlow switches. A lot of people, GENI is starting to gain traction. A lot of experimenters starting to sign up for GENI credentials and using GENI. This graph, a chart as of last week, shows the growth in the number of unique users creating GENI experiments, GENI slices. We are at about 700 plus unique users who have created slices, which is the container for your experiment in GENI. This is also the size of the experiments is growing, numbers of resources used. Examples of experiments that people are doing in GENI, I have 3 examples. These are from a couple years ago. All 3 of them are non-IP based experiments running on the national backbones. So an experiment from the University of Illinois, which is essentially better failure resilience in the network in case there are link failures and so on. They do, the routing decisions are made. Essentially, users select multiple paths through the network, and you can fail over from one path to another. So in today's network, when a failure is detected, then the routers talk to each other and decide on an alternate path. Here, the alternate paths might be pre-computed, so there's very little time to adapt. It takes very little time to adapt to failures. As a failure, you quickly switch over to a backup path. And they did this with non-IP protocols. Columbia University did a experiment with, it's a content distribution network. There was caching of content in the switches in the network, and so you can do a lot more if you actually have storage in your switches and cache content there. Weathercasting, the University of Massachusetts at Amherst has a large weather atmospheric sciences lab. They have weather radars which they federated with GENI. So you as a GENI experimenter can actually steer their weather radars as part of your GENI experiment. And it's essentially, you can think of it as a sensor from which you're getting large amounts of data. Happens to be weather data. And so they had an experiment where they, it's called nowcasting. So as opposed to a forecast where you get a 1-day, 5-day, a 3-day, 5-day forecast, if you want to know what the weather is, say half an hour from now, and I suppose you could look out of the window, but for some reason they had this application where they would get the weather data, send it to, create a layer 2 high-speed network to cloud computing resources at Amazon, process it there, come up with a really accurate short-term forecast, and send it to some kind of display. And Asterisk was from Stanford, really cool experiment demo. And what they had is they had servers at various campuses around the country, and they showed that you could do load balancing, as in sending traffic to these servers. Typically, decisions on where your traffic would go to which server is made at the ingress to your network. So at the entry point, you say, the last call or the last service request I sent to Clemson, maybe I should send this one to Kansas State. And so you make these decisions at the ingress. They actually move the decision making into the core into the network. And so dynamically, the network would decide, oh, this service request, based on what I know about the network right now, is probably best sent to Georgia Tech or wherever. And the demo was really cool. They had people in the audience pull out their cell phones and dial a certain number, which was essentially the entry to the network, and then they would, depending on traffic, direct your call to servers, one of these other servers, and you'd get a response. You might get a response from the server at Stanford, and your neighbor might get a response from a server at Indiana. So it was made for a nice demo. There are a lot of, we're doing a lot of training of GENI experimenters, researchers. Kaiki, who's around, runs a summer camp. The last summer camp, the next summer camp will be in probably June at the University of Connecticut. It's a week-long class camp for students, faculty. There's actually stipends that are offered for everybody selected to go. Lodging is covered, and airfare up to $400 or so. So you should, if not you, consider sending your students to those summer camps. They're great hands-on. It's a great way of learning GENI hands-on and actually doing a project with GENI. G. Albrecht, who's back there, has used.
What is the date? What is the date?
He doesn't have dates yet, so it'll be in June.
Roughly
Yeah, it'll be in June. After this GEC, he'll have a date. GENI Albrecht and others have taught classes using GENI. GENI Albrecht uses it in undergraduate classes. And there have been GENI tutorials at a number of conferences and workshops. The next one is at NSDI in Chicago, 2 weeks from now. And then I mentioned GENI in the classroom. In the fall of last year, we had a couple of people use GENI in their networking classes. This spring, JICAT at the University of North Carolina is using GENI for a graduate level class, and there are 2 classes at NCSC. One of them is a seminar class, and the other is a regular networking class using GENI. And in the fall, there are at least two classes planning on using GENI. There's a initial web page created for instructors planning on using GENI. It's got sample exercises, the instructor guides, and tips on how you might want to set up accounts for you and your students and your TAs. And if you're planning on running a class using GENI, please do talk to us. There might be other resources we might have to help you train up your TAs, because we realize training up your TAs is probably the most important piece in successfully running a class using GENI, and we are happy to help you with that. US Ignite was mentioned a few times. It's essentially, US Ignite is a White House-led initiative on deploying novel applications in cities with high bandwidth internet connections. So these are applications in the area of advanced manufacturing, health, energy, transportation, and so on. There are people in this room who probably know a lot more about US Ignite than I do. But essentially, if you're interested in building applications, there's a competition, there's a contest being organized by Mozilla Foundation. They're managing it. And you essentially put in your application, your proposal for, this is the kind of application I would like to build that I believe would be useful to a city with high bandwidth connectivity, useful for its citizens. And it's a staged thing. You put in a proposal, you get a little bit of money. If you get to the next phase, you get more money, and so on. And it's Ignite is meant to be a private-public partnership. What's next for GENI? Well, a large part of the GENI effort now is growing the scale of GENI, deploying to 100 to 200 campuses, and then as we do this in a spiral development fashion, so deploy some, grow every year. There. Here's Dr. Larry Landweber. Somebody wanted to know who he was. He's at Wisconsin, and he's the one you would talk to if you would like to get a GENI rack on your campus. This training for IT staff that happens on a regular basis. A lot of this training happens at the meetings where these IT folks go to, like the Internet to operators meetings and so mentioned international projects. G-Lab was mentioned. There are similar projects similar to GENI happening in many other countries, and we obviously exchange ideas with them, and we hope at some point to be able to federate with them. You will see a demo tomorrow where there's actually a GENI experiment that spans a research testbed in Japan, research testbed in Germany, the US of course, and then I think Brazil. So it's a demo that uses resources from all these different testbeds. All right, now to the demo and to some terminology you need to understand, not just for this demo, but for all the tutorials you might go to today and this week. So I already mentioned a slice. A slice is an abstraction for a collection of resources. The slice is a collection of resources that belong to you, that are assigned to you for your experiment. Your experiment lives within a slice. And when you create a slice, you essentially are responsible for your slice. You are responsible for anything bad that happens in your slice, and of course you take credit for anything good that happens in your slice, anything good that comes out of the experiment. So a slice has a slice owner, and the slice owner is responsible for content or whatever lives in the slice. A slice authority, you go to a slice authority to create a slice. There are 3 slice authorities in GENI. Actually, there's 4. There are 4 now. But Planet Lab, ProtoGENI in Utah, the GPO lab at BBN, and there's the GENI portal, which you will see at the next tutorial. But they're all slice authorities. You can go to any one of these and ask to create a slice. So when you create a slice, it's empty. There are no resources in there. All you have is this container with nothing in there. Now you go to aggregates. Aggregates are what hold resources, what own GENI resources. So as I mentioned earlier, Planet Lab, all of Planet Lab is an aggregate. The EmuLab testbed in Utah is an aggregate. A GENI rack at Houston is an aggregate. So you can go to any of these and ask for resources. So as a researcher, this researcher here, she first goes to a slice authority to create a slice. She gets back slice credentials. So the slice authority verifies that she's indeed allowed to create a slice and gives her credentials to this one slice. She can now go to various aggregate managers and ask for resources. She can ask them, what resources do you have for me? What resources, actually ask for resources. So so we come to the new term called sliver. The resource you get at an aggregate is called a sliver. So for example, if I go to the EmuLab testbed in Utah and ask for a virtual machine, that is a sliver that I get, that I can put in my slice. If I go to a regional network and ask for a VLAN with a certain bandwidth, that is a sliver. It's essentially my portion of this shared resource that I got from my experiment. Okay? So slivers are resources that are assigned to you and that live within your slice. So virtual machines, VLANs, they're all examples of slivers. Okay? Questions so far? All right. So a researcher here goes to these various aggregates, various resource owners, and asks for resources. Essentially, she's creating slivers. She's creating slivers at these various sites that she can use in her experiment. The way you negotiate for resources, ask for resources, find out what resources are available, is using this really low-level language. It's XML, RPC based. It's called RSpecs. Don't worry, you will hopefully never have to read or write an RSpec. Your tools will do this for you. But you just need to know what it is. So it looks like this. For example, this is the RSpec that describes a single node. Now you know why you don't want to write these. You want to use tools to do that. So, but there are 3 kinds of RSpecs. So one's called an advertisement RSpec. So this is what a aggregate uses to advertise what it has. So the EmuLab testbed at Utah, for example, its advertisement RSpec might say, we have 400 PCs of this certain class, 300 PCs of this other class, and we have so many PCs with wireless links on them, and so on. So that's the advertisement aspect. So it's essentially, you can go to an aggregate and say, list me the resources you have, and you get back an advertisement aspect. Okay? You can then look through your advertisement aspect and formulate a request. Maybe you want 5 PCs out of these 400. So you select the 5 PCs you want and formulate a request aspect. You're saying, I want these 5 PCs of these classes. Again, all this happens behind the scenes with your tools. I mean, you could choose to do this yourself by hand if you wanted to, but you probably don't want to. And then when you submit your request aspect, the aggregate, if it's able to fulfill your request, sends you back a manifest. Essentially, it says, this is what you got. You asked for 5 PCs. Here are the 5 PCs you asked for. Here are the IP addresses of the PCs. Here are the MAC addresses of the network cards on the PCs. Here are the operating systems running on the PCs. This is how you log into them. So it's got all the information you need to be able to use the resources you got. Okay? So there's the request aspect that goes in, which says essentially things like 5 PCs with 2 network cards each. Manifest comes back saying, here are the 5 PCs, here are the names of the PCs, here are the IP addresses, MAC addresses, and so on. Clear so far? All right, so let's do the demo. So what I'm going to do in this demo is go to an aggregate, say I would like 2 PCs, 2 raw PCs. So I'm going to ask for entire machines for myself. I'm going to call one server, I'm going to call the other client, and I'm going to install and run software on these PCs. And the software I'm going to run is really simple. I'm going to download a script from a website. All the script is going to do is install iPerf on each of these machines and run iPerf. So I can see that I can talk between the two and see what kind of bandwidth I get. And the tool I'm going to use is called FLAC. It's a web-based tool.
Need help? Need help?
Sure. I see my browser here, but I don't see it on that screen there.
I'll grab it.
I'm sorry? Well, I'm mirroring displays, so
Try clicking on data displays.
okay. It's back to my. Oh. Every time I switch to my browser, I lose the display. try unmirroring them to see what happens. Well, any suggestions? I tried mirroring displays, I tried unmirroring them.
Probably use a different browser.
Well, maybe try.
Something is not.
Right. Well, if I can get to my browser here.
What if you just disconnect the
Right,
cable?
yeah, maybe I can just do it from like this.
What if you just disconnect cable and put it back?
Oh, yeah. Great. Good. So I'm going to go to the GENI portal, which is a kind of a entry point into GENI, one of the entry points into GENI. I say use GENI. So this is what you'll be seeing in the tutorial that immediately follows this talk. You'll go to the GENI portal, and it'll ask you to log in. In my case, I log in through my home institution, which is the GENI project office. If you are logging in, you might be able to log in through your own home institution. So if you have an account at your university and it's federated with GENI through InCommon, you can log in through using your home institution credentials. But essentially, here I am, and the first thing I need to do in GENI is create a project. So a project is some experiments I associated with my project. And I already have a project created, so I'm just going to use that. And I have a project. I'm now ready to create a slice. So if you can see it, it says create. Can you see the screen?
Not very well.
Better?
Yeah.
Okay. So I'm going to create a slice. So remember, I said a slice is your experiment lives within a slice. So I'm going to create a slice. I'm going to call this C demo, and I'm going to create a slice. So it's talked to a slice authority, and it has created me a slice. I'm going to launch a tool called Flat. It's a graphical tool. It's easy to run simple, small experiments.
All this.
I'm going to have to run from the browser. I apologize for my head.
I think you want
BBN.com, right, sorry. There, I'm back. Use GENI. Use GENI Project Office as my identity provider. Continue. Allow. in, go to my sorry, delete back button. Too fast this time. Create a slice. I'm going to call it GEC16 demo and create a slice. Right. So now I have a slice created. I can add resources. I'm going to use, as I said, use the tool called FLAC, the graphical tool, to actually find my resources and assign them. So the tool's coming up. It's what it's doing is it's talking to the various aggregate managers, trying to see which one's up and what resources they have available, and it's going to list them for me. So for example, it's been able to talk to a InstaGenie rack at the GENI project office. It's been able to talk to a MU lab at University of Kentucky. It's been able to talk to see if I can make this bigger. There's a GENI rack at the University of Utah. So I'm going to So I'm going to go to this site, which is MU Lab, and ask for a raw PC. So I'm going to drag a PC from there and drop it here. So, so what this is doing behind the scenes is actually formulating a request RSpec for me. It's saying, oh, you want a raw PC? And it says, I want another raw PC from this same site. I'm going to drag and drop it here. And now I can connect them using a network. In this case, I'm just going to connect them directly. And so what it did was it automatically inserted a switch there. Now I can go to this node and I can say what I want to do with it. I want to call this a server. And I want to give a operating system to load there. I want a standard Fedora 10 image loaded. And I can give I can point to software that I want installed on this node. So in this case, since I don't do live typing in front of people, I already have a URL typed up. I'm just going to copy and paste that. And I'm going to paste that here. So what I'm saying is, go to this URL, pick up this script, and install it on /local of this machine. And then I can also provide an execute service. I can say, when this machine boots up, please run the script. In this case, the script I want run is what I installed. So I just want to run that script as root. So I have root access to this machine, so I want to sudo and run that script. And let's see, what else? I gave it a name, I gave it the URLs, and I can save this, apply this. Similarly, I can go to the client here and specify the name of the client, software to be installed. What I'm going to do, since we're running short of time, I'm going to finish my presentation, and then I'll do the demo. If you want to hang around during the break and see the demo, you're welcome to do that. You'll also be doing something very similar in the session right after this. Okay. So let me just finish up the presentation. And So this is kind of what it's going to look like. We'll do that. We'll do the demo during the break. But you're welcome to try this experiment at home. This is the Hello GENI tutorial that is on the GENI wiki. So you can do this very same experiment at home, at your hotel rooms. Please, if you can, do the hands-on tutorials at the conference. They start from really easy tutorials to the one that's happening right after this session in the same room, to advanced tutorials as the week progresses. And if you don't have a GENI account, do get one today. You can stop by the experimenter help desk that's somewhere at this conference, or you can email help@geni.net. As I said, yeah, and there's also the experimenter drop-in session on Wednesday afternoon. So if you'd like to learn more about running experiments on GENI, or if you have an experiment that you'd like to try to get working on GENI, do stop by the drop-in on Wednesday afternoon. And there's also a coding sprint experimenter tutoring session on Thursday afternoon. So please take advantage of these resources while you're here. And as always, you can always email help@geni.net, and somebody will get back to you. As for the conference, all the sessions marked with the little laptop are hands-on sessions. Excuse me. Most hands-on sessions require some pre-work. So either you need to have an account at the GENI portal. If you have not done the pre-work, please stop by the experimenter help desk, and somebody there will help you get started with an account. Some tutorials require a virtual machine. This is so you don't have to mess with installing tools on your laptops during the conference. We just have it all packaged in a virtual machine, so you can use that. If you don't already have a copy, get one at the help desk. Demo session this evening. It was a great opportunity to see the kinds of things that people are doing with GENI, what the experiments they're doing, the new features that are being built into GENI. And I mentioned the experimenter drop-in on Wednesday afternoon. Please go to that. Next GENI Engineering Conference is in the University of Wisconsin in July. Like this one, there'll be plenty of tutorials and workshops. If you're thinking of running a class in the fall, this might be a good place to send your TAs. And I mentioned GENI Solicitation 4. We're looking for proposals in these areas: experimental tools, advanced experiments, documentation training, operations transition, and transitioning of the GENI project itself with the community. There'll be more details tomorrow. Any questions?